Hello, in this video we are going to learn how to solve logarithmic equations. So before I start to solve logarithmic equation, I want to remind you the equivalency of a logarithmic term with an exponential term. So what it says that if logarithm of x base a equal to y, then equivalent exponential term is x equal to a power y. So we learned this factor before, but I just wanted to remind because I am going to use this equivalency a lot in this video. Also, another thing I want to remind the logarithmic rule. If I have logarithm of mn in multiplication form, then it is a logarithm m plus logarithm n. Or in a opposite manner, if I have logarithm m plus logarithm n, then I can write it as logarithm mn. Also, if I have logarithm m minus logarithm n, then I can simply write logarithm m over n. So quotient rule. Okay, so let's try to solve a pretty easy problem first, and then we are going to go move forward. Okay, so let's say I have a logarithm equation 4 plus 3 logarithm x base 2 equal 1. Okay, I have this equation, so I want to solve this equation. Right, so first of all I am going to isolate the logarithmic term and the constant. So I'm going to bring the constant on the right hand side, and I'm going to keep the logarithmic term on the left hand side. So 3 logarithm x base 2 will be what? 1 minus 4, which is equal to minus 3. Now in this left hand side I have a 3 multiplier, so let's divide both side by 3. So if I divide both side by 3, so on the left hand side I get logarithm of x base 2 equals what? Negative 3 over this 3, so it is basically equal to negative 1. And this is what? Logarithm of x base 2. Now this is what? A logarithmic expression. Now I want to express this logarithmic expression using the equivalent power expression. So what can I write? I can write x, this x equals what? A, what is my a? In this case 2. So 2 power y, which is negative 1. So what is 2 power negative 1? Which is 1/2. So this is my x. So this is the solution for this logarithmic problem. Okay, so that is the way we solve. So now let's solve some more problem. So let me choose another problem. So let's say I have this logarithmic problem, which is logarithmic x minus 3 base 2 plus logarithm of x minus 4 base 2 equal to 1. So this is my logarithmic expression. I want to solve it. Okay, now just to remind you what I have, logarithm. So if I consider this is my m, and if I consider my this term is my n, so what I have? Logarithm m plus logarithm n. So logarithm m plus logarithm n, I can write logarithm mn. So basically I can write logarithm of m. What is my m here? M is x minus 3 multiplied by n. What is n? My x minus 4 equal to 1, and my base is 2. Okay, so this is my logarithmic expression. All right, now let's see again. This is what? Logarithm expression. So I want to express this logarithmic expression in equivalent power expression. All right, So I can simply write down this. So I can simply write down x minus 3 multiplied by x minus 4. So I'm writing down this term equal to what? A. What is my A here? Base A is 2. So I have base A 2, and y, what is my y? This is power 1 is my y. So now let's expand it, let's multiply. I'm going to use FOIL method. So x multiplied by x, so this is going to be x square, x multiplied by negative 4, which is negative 4x, then negative 3 multiplied by x is negative 3x, negative 3 multiplied by negative 4 is positive 12 equals 2 power 1 is 2. All right, so now let's bring this 2 on this side. So what I have x square negative 4x negative 3x is negative 7x, then 12 minus 2 is plus 10 equal to 0. So this is a classical quadratic equation. So I can solve it using factoring. All right, so if I factor it, what I get? X minus 5 multiplied by x minus 2 equals 0. So I got x minus 5 equals 0 and x minus 2 equals 0. So I got x equal to 2, and here I got x equal to 5. So these are my probable solution. I am not going to claim that those are 100% solution, because I have to test this each solution in this equation. Okay, so let test 2. Okay, so I am going to, so let's do it here. So let's check x equal to 2. Okay, in which equation? In this logarithmic equation. Okay, all right, so what's the logarithmic equation? Which is logarithm of x minus 3 base 2 plus logarithm of x minus 4 base 2, and I'm going to see if this expression yield equal to 1 or not. So that is the reason I put a question mark. All right, so let's now substitute x with 2. So what I get a logarithm of 2 minus 3 plus logarithm of 2 minus 4, and I want to see if this expression is equal to 1 or not. Now let's see what I get. I get a logarithm of negative 1 plus logarithm of negative 2, and I want to see if this is equal to 1. Now we know that logarithm of any negative number does not exist. Okay, it is not possible to calculate a logarithm for a negative number. So that means this is not calculable. So that means x equal to 2 is not a solution. Okay, so x equal to 2 not a solution. Okay, so that is gone. So now I'm going to check x equal to 5. So let's check x equal to 5 in that equation. Okay, so what's that equation? Logarithm of x minus 3. So 5 minus 3, remember this is base 2, plus logarithm of x minus 4. My x is what? 5. So 5 minus 4 base 2, and I want to see if this expression yield what? 1 or not. So let's see what I get. I get logarithm 5 minus 3 is 2, and base is 2 of course, plus a logarithm of 1 base 2 and I want to see if it yields 1 or not. So logarithm of 2 base 2 is 1. Okay, that's from the logarithmic theory, and logarithm of 1 is 0. So this is what equal to 1. So that means what, my both left hand side and right hand side is equal. So I can say what's the final solution. So final solution is x equal to 5 for this particular logarithmic equation. Okay, so that's the complete solution of this problem. All right, so now let's solve another problem. So let's say I have a logarithmic equation, a logarithm of x plus 4 base 2 minus logarithm of x plus 3 base 2 equal to 1. All right, so again this is if I say this is my m and this is my n, so this is logarithm m minus logarithm n, so I can essentially write logarithm m over n. So logarithm m is x plus 4 over n, which is x plus 3, and my base is 2 equal to 1. Again this is an logarithmic expression, so if I now write down equivalent exponential expression, so I can write down my this essentially x. So this is my x is what, x plus 4 over x plus 3 is what equal to base a, so a is 2 power this 1. Okay, so what I get x plus 4 over x plus 3 equal to 2. All right, so now let's multiply both side by x plus 3. So if I multiply both side by x plus 3, so this this x plus 3 and this x plus 3 cancel out, so I am left with x plus 4 on the left hand side equals 2 multiplied by x is 2x and 2 multiplied by 3 is plus 6. So what I get, let's have x in this side and this 2x let's bring on the left hand side, so it is negative 2x equals 6 is 6 and 4 on this side is going to be negative 4. So I get negative x equal to 2, so x equal to negative 2. Okay, so again of course I need to check it. I need to check negative 2 in this equation, and if you check it you are going to find this will going to be okay, so check it. Okay, it will be okay. All right, so what's the final solution? So we can say the solution for this problem is x equal to negative 2. Okay, all right, so that is basically two example with using product rule and quotient rule of the logarithm. All right, now let's solve some final problem where we are going to use basically one-to-one property of logarithm. Okay, so we are going to use what, one-to-one property of logarithm. Okay, one-to-one property. Let's see an example. Okay, so if we see an example it will be clear for us. Let's say I have a logarithm of x base 4 plus a logarithm of x plus 1 base 4 equal logarithm of x minus 1 base 4 plus logarithm of 6 base 4. Okay, so these are my logarithmic expression. Okay, so now let's see how I can solve this equation. Okay, so I am going to do it on first I'm going to try to combine on the left hand side. So I have logarithm m and logarithm plus logarithm n, so I can write logarithm m multiplied by n and my base is 4. So this is my this left hand side. Okay, so now let's look at right hand side. So this is my m for and this is my n. So logarithm m plus logarithm n, so this is a product rule, so I can write logarithm m, which is x minus 1 multiplied by n is 6. Okay, and what is the base? Base is 4. Now if you notice, I have on the both hand side I have logarithmic base 4, I have logarithmic base 4. So what can I say? I can say this quantity is equal to this quantity. Okay, so I can essentially write x multiplied by x plus 1 is equal to x minus 1 multiplied by 6. All right, so let's simplify this expression. So x multiplied by x is x square, x multiplied by 1 is plus x, equals x multiplied by 6 is 6x and negative 6. So if I group together again, so bring everything on the left hand side, x square plus x minus 6x plus 6 equal to 0. So more simplification, so x square minus 5x plus 6 equal to 0. So if I now factor it, so it will be x minus 3 and x minus 2 equal to 0. So I get x minus 3 equal to 0 or x minus 2 equal to 0. So I get x equal to 2 and here I got x equal to 3. Okay, now again we have to check both x equal to 2 and x equal to 3 in this original equation just to see if this work. So what we need to do, check it and also check it. Okay, so if you check both the number into this equation, you are going to find that both the number works. So finally what can I say, what is going to be my solution? So my solution is x equal to 3 and x equal to 2. All right, so this is my final solution for this particular problem. Okay, so that is the way you try to solve logarithmic equation. So thank you very much.